Hello guys, good morning. This is the air cooled chiller. You can see the chiller here. See, this is the chiller. Makeup is Climaveneta, Climaveneta, Climaveneta. This is a 300 ton of refrigeration. 300. I will show you the one by one parts. This is the evaporative coil tank. Here the heat exchange between the chilled water and refrigerant takes place. This is the evaporative tank. This is a compressor with oil separator. This is a screw type compressor. Here you will see two compressors. One is for standby and one is for working. See here two compressors are there. One is for standby and other one is for working principle. Okay. This is an air cooled condenser. These are called as fins, condenser fins. So first of all I will tell you about the compressor. See, this is a compressor. You all know the working principle of compressor. That is compressing low pressure and low temperature of refrigerant to high pressure and high temperature of refrigerant. From here, from the evaporative coil tank, the refrigerant goes through compressor, and from compressor, by compressing and then separating the oil from the compressor, that is from refrigerant, it will go to the air cooled condenser. See, here you can see. From here it will go to the side. Okay. These are called as fins. From the compressor it goes to the condenser, where high temperature and high pressure refrigerant decrease to by decreasing some temperature, that is refrigerant. For example, in compressor the temperature is 45 degrees, and in condenser, by removing the temperature of the refrigerant, for example, it will be after condensing, it will be for example 20 or 15 degrees or maybe 30 degrees, like that. Okay, this is the condenser. I will show you from the top how the condenser fans are there. Actually today, just wait a minute. Fans are provided for removing heat from the refrigerant. I'll show you from the top. See, there are about 16 fans are provided for removing heat. For condensing, that is removing heat, that is the vapor refrigerant, converting the vapor refrigerant into liquid form. It goes through the dryer and filter. I'll show you what is dryer filter. This is a 300 ton of refrigeration capacity. after condensing. From here it will goes to filter and dryer, called as economizer sub-assembly, something name is I will show you. Simple called as filter and dryer. See, this is a filter and dryer. I will show you from the other side also. This is a filter and dryer. The principle of working principle of filter and dryers: filter is used for removing impurities and any particles or there, light, dust or anything, it will remove, and the dryer for trapping of water. If there is any water content is there in the refrigerant, the water will remove. You can see this is the diagram is there. Filter shell with recapable solid coats for filter block for liquid and suction lines. Okay, this is the flight version. After trapping of air and impurities, it goes to evaporative tank. You can see from here it will go from condenser lines, after going through filter and dryer, then it will go to evaporative tank. This is the evaporator tank. You can see this is called as evaporator tank. You see this is shell and tube form. In evaporative tank, heat exchanges take place between water, which is for example tube in shell form, and in tubes the refrigerant will be there. From here then exchanging heat, then the refrigerant goes to compressor once again. I will show you how the water comes. Okay, I will come by water pumps. These are the water pumps used for suction of water from the buildings. From here it will come through this. See, in first there is a white strainer. This is called as white strainer. If you want complete details about white strainer, then check my other videos. This is the pressure. Because this is in off position, so it will right now it is showing in 0 position. Okay. From then this is a motor is a pump is a centrifugal pump. After sucking the water, that is chill water return. Okay, chill water return, it will suck. This is called as a core bellows. Okay, it will reduce the vibrations. For removing vibrations or reducing vibrations, core bellows are used. After then core bellow, there is a butterfly valve. This is called as a butterfly. And here also you will find 2 pumps. One is for working, another is for standby. See, I will show you in clear diagram. See, there are 2 pumps are there. One is for working and one is for standby. If there is any problem occur with one motor means, then they will start another motor. After increasing the pressure, from here you see, from here it will go to the evaporator tank. In evaporator tank also butterfly valve is there, and here you can see the temperature because of chilled water return. Because of chilled water return, 21 or 22 degrees temperature is there. In chilled water return, the temperature will be low, and chilled water supply, the temperature will be chilled water return, the temperature will be more, and in chilled water return, temperature will be less than 20 or like 18 degrees. Or this is a evaporator tank. From here, the heat exchange will take place, and here also you can see bellows. These are the bellows for decreasing the vibrations. Then from there, from here, this is the chilled water supply. Okay, chilled water supply. Here this is called as a balancing valve. This is called as a balancing valve. Okay, this is a temperature gauge, and here you can pressure gauge, temperature and pressure. This is also a butterfly valve, and this is balancing valve. Okay, like this the process will continue. In simple I will tell once again. In evaporator tank, the refrigerant which is in low pressure and low temperature, and chilled water return. That is, from here the chilled water return exchanges heat in the form of shell and tube form. Then the refrigerant flows to the compressor after exchanging heat from the refrigerant tube, that is in tube form, and in shell in tube water is there, in shell refrigerant is there. Then the vapor, after exchanging heat, when the refrigerant converts into vapor form, it will goes to the compressor, and then the process goes on, continues. Okay, I will show you again from this. See, after balancing, how much the water we have to flow, how much the water required for flowing, it will lock. We will see here a lock is there. It will lock. Okay. If any problem it will occur, if they want to increase the amount of water, they will increase and lose it, then the flow will occur. Okay guys, I think now you will understand. If you have any doubts, please comment below. And here you will see R134A, the refrigerant is used. See, R134A, total weight is, operating weight is 8030 kg, that is 8 tons, and refrigerant is R134A. Okay guys, okay, thank you so much. If you have any doubts, please comment below. I will try my best to clarify your doubts. Okay.